Alright, then welcome back everyone. Let's solve this question, relative editing. So this question is an easy question, but how you arrive at the solution is very important. So you can show you the solution and you'll be happy, but it's better if you understand how I reach the solution here. So of course you have to use map here, but how do I reach, like how do I figure out, okay, I have to use map here is a real deal here. So I hope you read the question once. So basically the question is like this, this girl, Daisy, picks up a word, determined, and then this guy, Daniel, calls out letters one by one. So, and whenever Daniel calls out a letter, you remove the first occurrence of that letter. Okay. Now, what we want to figure out is if she can get the final word of her choice starting from given initial word. So, basically, after calling out some letters, can she get the final word? Basically, for example, if DC starts from determined, can she get like, see, she can get TRME, right? So, depending on like various calls. So, first he calls out E, then D, so on, right? So, basically, they have shown here. So, from determined, you can get TRME, but you cannot get term. You cannot get term because if you want to get term, this E needs to be removed. But if this guy calls words, like if this guy tries to delete letters, this E will always be deleted first, right? So this first E, like the second E will be deleted before third E, so you cannot get term. Okay, so that I guess you would have seen. So what we want to find out is we are given two words basically, S and T. We want to find out if by removing letters from S. So basically letters are called out from S, right? So this guy, I think it's Daniel, calls letters from S, and we want to remove it. Basically, whenever he calls out a letter, the first occurrence of the letter is removed. Okay, and T, basically from S, can we get T by removing letters? And if it's possible, print yes, otherwise print no. Okay, so if it's possible to create T from S, print yes, otherwise print no. Okay, so how do you approach this question? First things first, I just took the same word they have told, but I just added some more letters to it. So I just wanted to see how are words being created. So the first things first, let's say we wanted to create this TRME, right? TRME. So after calling out some letters, we want to create this word TRME. Okay, fine. So in the end, you agree with me one thing that if you want to form this word TRME, it doesn't really matter in what order the letters are called out, but all the letters except these four have to be called out, right? So it doesn't matter because in the end, those other letters needs to be removed, right? So irrespective of this TRME, this rest two T's, this M, so on, right? Basically, the rest of the letters have to be removed. So it doesn't really matter in what order you call out, but you have to call them out. So that's fine, right? So the order of calling the letters doesn't matter, but they have to be removed. So how do you do it? So basically, what I thought is, let's keep it very simple. Usually, like I guess it's a div 3 question, yeah, div 3D question, or div 4D question, I guess. So it will again be very easy because it's marked easy. Usually, div 3D, div 4D is relatively easy only. So what I thought is maybe let's just try to do a simple kind of string matching. So basically, what I'm saying is I'll just put a pointer here and I'll put a pointer here. And whenever a match occurs, what I can do is I can increment the pointer here. I can increment the pointer here. I can increment the pointer here. Whenever a match happens, okay. So whenever I found out, okay, a letter is present there, I can move this pointer. And eventually, if this pointer reaches at the end, so basically, maybe if this pointer you call it as J, if J has become this is T, right? This string is T. So if J has become a T dot size, then yeah, my job is done. So this is what I was thinking. Okay, so I'm just see when you're thinking about the solution, don't think about the code. How are you going to implement the code? So just think maybe can I do something like this? Okay, don't think about the code right now. Code we can handle it later on. So just think about the approach. What you want to achieve. So here I wanted to achieve like maybe I can just whenever a match occurs, I can implement the pointer and don't think about the details. Okay, how are you going to figure out a match occurs or not? But maybe if match occurs, I can move the pointer, and when pointer reaches at the end, I can be sure that okay, this T can be formed. Okay, fine. So how can we achieve this? How are you going to achieve this is the question here. So you want to find this TRME, right? Fine. So we'll start from first. So first things first, are these two guys equal? D and T equal? Are D and T equal? If D and T are not equal, you can assume that you can just remove D, right? So you can say Daniel calls out D and D is removed. Fine. So that is simple. Now is E and T equal? Is E and T equal? Is E and T equal? E and T is not equal. E and T is not equal. But you might say that okay, this E is present somewhere here, but it doesn't really matter. See, if you want T to be first, this E has to be removed, right? So if this is not matching, even if it is present somewhere here, it has to be removed. It has to be removed, right? So that's obvious. So this also is not matched. So this E also needs to be removed. This E also needs to be removed. Okay, fine. Now this T is matching. Now this T is matching. Now what you should do? So this T is matching. So should I increment this pointer because this T is matching? Should I increment this pointer because T is matching? You see here, there are some more T's here, right? There are some more T's here. So when you call out T, first these two T's have to be removed, right? So you cannot match this T with this one, because you only want one T in your answer, right? So these two T's have to be removed. This T has to be matched with this T, or basically you can see here the last T, right? So this T needs to be matched with the last T here. Okay, cool. So basically you cannot match with this. You have to move ahead. You again cannot match with this because you still have two more T's, right? So this T has to be matched with the last T. Okay, so move ahead. Don't worry, understand it. I'll take one more example. So we're building up the solution, right? So yeah, fine. So we are here. Now this T will be matched. Now this T will be matched. So now you can increment this. So what happened here is Daniel called out these letters D, E, T, T. Okay, so these letters are gone. So now you are basically, now the starting letter of T is formed. This is what it means. When this pointer is moved, what it means is the starting letter of T is formed. Daniel called out all these letters. That's what happened. Fine, let's move ahead. So okay, so this is also match. So this will not, like, this pointer will always move, right? Whether you match it or not. If you match it, then good. If you don't match it, so if you basically if you match here, then it stays. Otherwise, you delete it. So that's why the above pointer always moves. Fine. E and R matching. So E might be here, but E might be here. But I want the second guy to be R. So this E has to be removed. So this E will be removed. This E will be removed. So we are here. So R is matched. Important thing is, are there any R's in the end? Are there any R's? Because see, there is a single R here, right? So if there is a R here, there is a R here. I have to wait for it. I have to wait for it because see, if there were more R's here, they will be removed first, right? Before the last R can be found, right? So basically, now since you know that only one R is here, so basically here only one R is present, so this will be matched. Okay, so this is matched. Fine. Now again see, M. So you only wanted one M and only one M is present here. Okay, if there were two M's here, if there were two more M's here, you cannot match this M with M. Why? Because you'll have to remove these two M, right? Then only like when Daniel calls out letters, first two M's will be removed, right? So this M and this M will be matched. Fine. Now move ahead. So will I will be matched? No, I will be removed. Will N will be matched? No, N will be removed. Will E will be matched? Will E will be matched? Are there any more E's? Are there any more E's? See, what is the significance of making sure there are no E's remaining in the end? The significance is, if there are E's here, this E cannot be matched. Why? Because this E will be removed. This E will be removed, right? Okay, fine. So this E will be matched here. Fine. And finally, the pointer goes, J becomes T dot size. So at this point, you got your answer. At this point, you got your answer. So here pointer comes here, but pointer is here. So you can anyway remove this, remove all of three. So that's not a big deal. So like the point is, our condition gets over once we are here. Basically, once J becomes T dot size, our condition is over. Okay, fine. So this you got it. Let's do one more dry run. After that, we can maybe start thinking about the code. Okay. So I'll start with 2 pointers here. Okay. Maybe now I'll name them. So maybe I'll call this I and I'll call this J. Okay. This D and T are not matching, so this D needs to be removed. Fine. Move this pointer ahead. Now is E and T matching? No, E and T is not matching. So despite the fact these E's are here, but I know my word, the target word starts with T. So unless a T comes, I cannot do anything, right? This E has to be removed. Okay, fine. So this E is also removed. This E is also removed. Again, don't think about the code right now. Okay, only focus on building up the solution. Okay, what you are requiring. Don't think about the code, because this is a common mistake in beginners. They try to think about the code. Just think about the approach first of all. Okay, we come here T. So TTRC, but is it a match? Is it a match? See guys, in your word, the target word, you have 2 T's, but from this point there are still 3 T's remaining, right? You cannot have this T. This T cannot be matched because this T has to be removed, right? These 2 T's will be matched here, right? So basically, still this T won't be matched. Why? Because the number of T's remaining here are still more, right? There are still 3 T's, but you need only 2 T's. So this cannot be matched. Okay. So of course, if there were some more T's here, you cannot start matching unless you remove all of them, right? So Daniel needs to first call out this this remaining T's, like the extra T's. So this T also won't be matched. So this will be removed. Okay. So this will be removed. This will be removed. So these are removed. These are not matched. Okay. Match means this will be kept. This will not called out by Daniel. Fine. So now this T can be matched. Notice here, we want 2 T's in our target and 2 T's are remaining. Okay. Fine. So this is a match. Cool. So if this is a match, I'm going to move this J pointer now. Okay, so the T is matched. So now this letter won't be called. Again, TT remaining. So there are no more T's here, and only 1 T is required. Yeah, this is a match. So then I won't call out this T. Okay, fine. So match. Okay, now there is a E here. Despite the fact I need E here, I want R in my word, right? I want R in my word. So this E cannot be matched. This E has to be removed. This E has to be called out by Daniel, right? This E will be removed. Let's move ahead. R. So notice the fact here, you only need 1 R and only 1 R is there. There are no more R's here. Right, there are no more R's here, because you know the way Daniel calls R is the first, like basically the first occurrence of a letter is removed. So there are many more R's. You cannot remove these R's. These R will be gone first, right? So that's the thing. So what I'm saying is, if there was a R here, there was a R here, this R cannot be still considered a match. Why? Because you cannot remove this 2 R without removing this R. Okay, this R will be matched with the last R only, because you need 1 R, so only 1 R should be remaining. So here only 1 R is remaining and only 1 R is there, so this is a match. Okay, cool. Let's move ahead. Okay, so R is matched, right? So M. You want only 1 M and this is the last M. Okay, so this is the last M. If there were M's here, you cannot match it, because this M's cannot be removed without removing this M. Okay, so you can only match this M when you have only 1 M remaining there. Okay, because the rest does have to be deleted. Fine. So this is a match. I'll move ahead. Is I any matching? No. Right. So remove it. And any matching? No. Remove it. Okay, this is an interesting question. Can you match this E here? Can you match this E here? Think about it. Basically, what just happened here? There is a match, fine. There is a match here, fine. Okay, so you might think I can match it, but notice that you don't have any more e's remaining. So basically in this part, only this part, you have only one e, but what you require is, you require two e's, so what happened? The remaining t's are less, than you require in the target. So in this case, you can anyway return -1. You cannot form your letter, right? You cannot form your letter. Okay, and you can return -1, or maybe you can say I cannot match this, since basically your requirement is of two e's, but you only have one e remaining. In other words, you can see it like this. Okay, so these e cannot be matched. You can basically stop your loop here in itself. Basically, you can stop your iteration here in itself and return -1. Okay, let's just see there was e present. So what will happen there? So there are two e's present here. Okay, there are two e's present here. Then you can match it, fine, because you require two e's here and there are two e's. Okay, then you can match it, no issues. So let's match this. Okay, fine. Now can this be matched? Yeah, I only need one e and one e is there. Okay, fine, there is a match. Good. Let's move ahead. Now anyway, this you're going out of bounds. Okay, so whenever I guess you have reached the end of the first target string, wherever you reach first end of the target string, you can definitely your answer exists. Why? Now wherever the pointer is, you can remove all of them. Fine. So I guess the dry run is a little bit clear. Now let's try to think about the code. Okay, let's try to think about the code. Let's just dry run it again and think about the code. How can you write the code? Okay, so now think about the code. Okay, so I guess we have spent enough time in thinking about the approach. Now it pays well to think about the code. Okay, fine. So that will give us idea what type of data structures we have to use. Okay, so let's say j is here, I is here. Okay, so I can maybe initialize I equals to 0, j equals to 0. Okay, fine. Now at this point, what I need is basically, of course, I'll need to run a while loop, right? I need to run a while loop till when? I don't know. The condition may be till we have ran out of this string. Okay, something like this. So because in the end, see, even if this is not matched, we'll keep on going through this string. So basically, if there are no matches, let's say if there was a string something like this, ABC, this will never be matched. So eventually, we'll run out of this source string. So yeah, I guess this condition is fine. While j is less than, maybe I can call this size m, and so basically, I'm calling this size of s to be m and size of t to be n. Okay, fine. So while j is less than m, we can go ahead. Fine. So cool. So that's how we can go. Okay. First things first, what do I need? Are these two matching? So basically, of course, I need to first check are they equal. Is so j. Okay, I have to write here I, right? So this has to be I less than m, I less than m. Fine. So first I need to check is s of I equals to t of j. So first of all, check if they are equal or not. Matching and not that you can find later on, but first of all, they have to be equal, right? So if they are equal, first check that. Okay. First check if they are equal or not. So if they are not equal, move ahead. Anyway, you have to move ahead every time, right? So if they're not equal, then you'll only move this I pointer, right? So basically, I'll check the match condition. So I'll check the match condition here when they're equal, because they can match only if they are equal first of all, right? So if they're not equal, anyway, we'll do I plus plus. Okay. If they are equal or not, I plus plus has to be done. It's just you have to figure out whether I have to increment this pointer or not, right? So in both the cases, I has to be incremented. So I've written it like this here. Okay. Anything else? Yeah, I guess this seems fine. Maybe I can take it a little bit above. Okay. Okay, fine. So this seems okay. So we can complete the while loop here. Cool. Now what? If they're not matching, then anyway you cannot do anything. So delete. Okay, now so these two are equal, right? So is there a match? When can you say there is a match? When the number of t's here, the available t's here are what? Are equal to number of t's you have, right? Unless the t's are equal here, you cannot say there is a match, right? So basically, what I need to check here is So what I need is how many number of t's are present after this index. Right? So I need to check these number of t's should be equal to the number of t's I want. Otherwise, I cannot have a match. Right? Otherwise, I have to just delete this t as well. Okay, see guys, what I'm saying is if they are equal, there is a possibility of match, but they cannot match every time. This can only match if the number of t's here are equal to this, right? Number of t's are equal to this. So what you need is it shows you that you need some concept of map here. So here you need something like this. You need maybe I'll call it S map of let's say this character I'm calling it C. Okay, this character I'm calling C. S map of C. So basically C is equal here, right? So if they are equal, that S of I is also C and T of J is also C. S map of C equals to T map of C. Okay, so what is this S map and T map of C? It basically returns how many T's are present after this, Okay, if they are equal, then definitely there is a match. So then you can increment J. Okay, then you can increment J. Otherwise, you cannot increment J. Okay, fine. So here J won't be incremented. But anyway, this part will be run and I will be incremented. Okay, so this T is gone here. Now come here. Now here again, S of I and T of J are equal. S map of T is 2 here and Sj of T is 2 here. So yeah, these two T's are matched. So basically, this T is matched here. So we can move ahead. This pointer, but this time J plus plus also, right? So J can also move ahead. Okay, so that T got matched because you only had 2 T's remaining and you were requiring 2 T's. Fine. So now let's see. Can this T be matched? The number of T's. Okay. So now what you want is the number of T's here requiring is 1, right? So maybe you need to do some update here. You need to do some update here. The maps needs to be updated because now you need to make sure that number of t's remaining is 1 and number of t's required is also 1. So along with it, you might have to do update here. So here t map has to be updated. T map of c will reduce, of course, and here, of course, every time s map reduces, right? Because anyway, we are moving the character. So every time, so maybe if I have to be 6 into s of 5 minus. Okay. And here c is equal to both. That's why I just written t map of c. But basically, what I'm saying is when I move ahead, when I move the pointers ahead, of course, the frequency of the frequency of every character needs to reduce, right? And here, the frequency of this character only reduces when there is a match. Right? So this is a case when there is a match. So basically, I'm maintaining a running sum of frequencies. I'm maintaining a running frequencies. So at a given point, my map represents what is the frequency of characters in this part. At a given time, the map represents what is the frequency of this part. Okay. So that I got to know by just looking at the dry run. Okay, fine. So here again, of course, both the t's, one t is required and one t is required. So fine, this will be a match. Move ahead. Come here. Not equal. So delete it. Okay, equal. How many r's are required? Only one r is required, and only one r is there. You can happily perform a match. You can happily perform a match. Move ahead. How many m's are required? Only one m is required. How many m you have? You have only one m. So move ahead. Fine. Not matching, like not equal. So matching is not out of picture here. Not equal. Okay, E. Now this is an interesting case. See, okay, it is equal. Fine. So that might be a case of match, but the number of E's here are less compared to what you want. So in this case, you can be definitely sure answer is not existing. So what I can write here is I can write a condition here. You can write a condition here. What condition that can be is if S map. So if they are equal, fine. But if S map of C is less than T map of C, less than T map of C, you can by default print no, right? You can by default print no and return, right? Because you know, see, you don't have much characters here, so there's no point here, right? So there are no more E's here. You will never be able to form this E. But if there was E here, let's say if there was E here, then of course now you want only two E's and two E's are there. Fine, move ahead, move ahead. Okay, the frequency maps will be updated. Okay, move ahead. Fine, this goes out of bound, and eventually, what can you do is yeah. So now, of course, when you reach here, you might have to write a condition here. So maybe this while loop, you also have to inculcate the condition I less than m and j less than n. Okay, because now this has gone out of bound. You don't want the checks to be made, right? So now basically the loop will exit because since the j has exceeded, j has become n. So this loop will exit, and in the end, you just need to check one thing. You need to check one thing. See, what can happen is either I can reach the end or j can reach the end. Okay, this loop will exist in both of the cases. So let's say in this case, yeah. So basically, these two things can happen, right? In the end, you can just check one thing. If j is equals to n, or basically t dot size, you can see the entire string was matched. Okay, so you can in then return yes. You can then print yes. Fine. I'll quickly summarize what we did here. So we first dry run. We just performed some dry run with example. Then we found out what happens is, first of all, what I did is I try to put two pointers here and try to create this string t. So already I try to create it. I'll first check, are the characters equal? If they're not equal, anyway, this guy needs to be removed. Okay, if they are equal, but that is not enough. There is a chance of match, that's not enough. What I wanted to check is the number of characters that you have should be same as number of characters that require here, right? If it is not same, remove it. If it is not same, remove it. If it is less, then anyway, the answer is no. Okay. If it is greater, move ahead, don't match with this. Greater than move ahead, don't match with this. If it is equal, yeah, then match it. Match it. How do you match it? Basically, increment this j. Fine, that's how you match it. And eventually, what can happen is if this entire string is matched, this j pointer will reach to the end. J pointer will reach to the end. And finally, you can just check if j is equal to n. Yes, then print yes. If at some point, like you need more E's, for example, this E was not here, and you come here and you require more E's here, that you can check and print no. Okay, fine. So basically, your requirement was more, but you don't have that many characters. In that case, also you can print no. Fine. So yeah, I guess that's that. So let's just quickly code it up, and then I guess you'll finally understand everything. Okay. So I'll explain it one more time while coding. So this is pseudocode, by the way. Okay. I'll explain one more time during coding. But yeah, that's that. So instead of directly telling you map is used here, I thought maybe let's just try to see how can you reach to the point where you yourself know, okay, I have to use map. Okay, fine. So let's just see how to code it up. So first things first, I've just taken the input here. What we need here, we need a map here, right? So we'll need to create frequency maps for both of them. So map of what? Char to int, right? And you know, you should always prefer map and sets apart from the unordered counterparts. For simple reason is, I know, like when you give a random input, unordered and unordered sets have a constant, like average time complexity of order 1. But what happens is, when people try to hack your solutions in Codeforces, they will not provide random input. Okay, so because of collisions, your unordered versions will basically the average time won't be 1, then it will start to be order of n, because people will deliberately not give random inputs to hack your solution. So always prefer map and set because they guarantee the time complexity will be log n for each operation, like insert, delete, and access basically. Fine. So that's a little bit aside note for you. Always prefer map and set contrary to that unordered versions. Okay, so let me just create the map quickly. Auto ch s m1. So m1 is a map of our input string basically from which you have to create t, m1 of ch plus plus, and then let's create a map for the target string m2 of ch plus plus. Okay, then what do we need? We need our 2 pointers, I equals to 0, j equals to 0, right? These 2 pointers are required. Then what do we need to do? While I less than s dot size and j less than what? T dot size. Well, I less than s dot size and j less than t dot size. What you need to do is, if first of all, what do you do? First of all, the characters have to be equal. If s of I equals to t of j, if they are equal, then there can be a chance of match. When can then be a match? If the number of characters after this point are equal, in both the strings are equal. So m1 of si equals to m2 of t of j. I could have maybe stored them in one of the variable, and since they both are same, right? m1 of s of I and basically s of I and t of j are equal here, but anyway, fine. If this is equal, then basically this is a match. This is a match. The characters are not equal. This is a match. So what we need to do is we need to move the j pointer. But since we're moving the j pointer, the frequency needs to be reduced, right? So basically, the frequency of this character to reduce in the inputs, basically the target string, m2 of t of j minus minus. But anyway, in the end, like uh, every time you have to reduce the frequency of the target string, because anyway, either you're deleting it or matching it. The target string, sorry, the input string, the frequency of a character always reduces. So m1 of s of I minus minus and I plus plus, right? Anything else? Yeah. See, if the characters are equal, but in the first frequency map, basically in the input string, the character's frequency is actually less. The character's frequency is actually less than what we desire in the target string. So in this case, so s of I, tj both are equal. So in this case, of course, you need to return false, right? So of course, in this case, what you can do is you can just break. You can of course print no and return as well, but yeah, we just break and we'll just handle the case here only. So here, what I can do is now, if j has become t dot size, basically I have matched the entire target string. I'll just print yes followed by a new line, else I'll print no. Okay, so that's the code basically. So let me just quickly summarize this. So this is the input. This is just the input I've taken. This is the frequency maps I've created. Now I'll put in 2 pointers I and j. This loop I'm running till both the pointers are in bound. Okay. Then what I'm doing is, when can there be a match? First of all, the characters have to be equal. But just the characters being equal is not going to help, right? If, for example, in our input string, the characters are less from this point, definitely you cannot make it. Definitely you cannot make your target string. You have to break. Otherwise, if the frequencies are equal, frequencies from this point on are equal, yeah, makes sense. We can have a match. So increment the j pointer and decrement the frequency. Why decrement the frequency? Because next time we need less number of that match character, right? For example, we earlier had matched 2 t's, but if 1 t is matched, we need only 1 t to be in match next time, right? Anyway, the frequency, since either we are deleting a character of input string or we are matching it, the frequency anyway has to be reduced when we go ahead. Okay, and in the end, after everything, this loop will exit. This loop will exit in one of the cases, right? If all the characters are matched, okay, or maybe here it can exit. So maybe you can get rid of one of these conditions, but fine. I just want to be safe. Right? In competitive programming, you have to be safe. And in the end, if entire target string is matched, you can print yes, otherwise print no. Okay, let me just quickly run it. So yes, no, yes should come, right? Okay, so I found out the mistake. Mistake was I've written j plus plus before, right? You cannot do that. You have to first decrement the frequency and then increment j plus plus. Otherwise, the character might be completely different. So yeah, I guess you might have noticed this. This was a silly mistake from my end. Apologies for that. So yes, no, yes, fine, it works. Let me just quickly submit it. And it works. Thank you for watching. I hope you got something out of the video. I'll see you in the next one.